Good evening, all of you. Today we will be discussing a new chapter, chapter 3 of class 8, understanding quadrilaterals. Okay, and first thing that I am going to tell you is what you mean by a polygon. Okay, we will be studying about different types of polygons in this chapter, and first let's see what you mean by a polygon. Okay. So polygon means what? It's a simple closed curve which is made up of only line segments. Okay, it will be a simple closed curve made up of only line segments, and I will give you examples, then you will understand it. Okay, you can see that all these are examples for polygon. Okay, first one you can see that it's simple, it's a closed one, and it's made up of only line segments. Here also you can see that this is simple, it's closed and made up of line segments only, and this one also, and this also the same thing. Okay, now let's see some examples where they are not polygons. Okay, now see this, can you say this is a polygon? This one? No, this one is not a polygon. Why? It's not. It's made up of line segments, of course, but it's not closed. So you cannot say that it's a polygon. So you cannot say this as a polygon. Now I will show another example. Now see this. What about this? Is this a polygon? This is made up of line segments only, and at the same time it's closed also. But this is not a simple one. This is not a simple one. So you cannot consider this as a polygon. Okay. So a polygon should be simple, closed curve which is made up of only line segments. Okay, all these three conditions should be satisfied. It should be simple, it should be a closed curve, and it should be made up of only line segments. So such things you can call it as what? Polygon. Okay, now you understood what you mean by a polygon. It can be 3-sided, 4-sided, 5-sided, 6-sided, any sided. In this case, you can see that all the conditions are satisfied, but it's not a simple one. It's a complex curve. So that should not be considered as a polygon. Understand? And now we are going to study two different types of polygon, which is convex polygon and concave polygon. So now let's see it. So convex polygon and concave polygon. So let's explain or let's define both these polygons by taking some examples. Okay, and you can see the difference between those polygons when you are observing the figures. Okay, so let me draw it. First one is convex polygon and the second one is concave polygon. So now let's see the difference. What all are the difference between the two polygons? Okay. In the case of convex polygon, you can see that none of the line segment goes inside. Okay, none of the line segments goes inside, or no line segments between 2 points goes inside in the case of convex polygon. But in the case of concave polygon, you can see that some of the line segments may go inside. For example, here you can see that these two line segments are going inside. Okay, so that is the main one difference. So convex polygon, you can see that no line segments between 2 points goes inside. That is the first main property. Here I am writing the properties of convex polygon, and the properties of concave polygon will be just opposite of this. Okay. So in the case of convex polygon, you can see that no line segments goes inside. So in the case of concave polygon, what is there? Some of the line segments may go inside. For example, you can see here these two line segments. These two line segments are going inside. Okay. Now let's see the second property. What is the second property? You can see that in the case of a convex polygon, all the diagonals will be lying inside. Okay, all the diagonals lies interior of it, interior of the polygon. Okay, that means here you can see that what are the diagonals? Diagonals means what? Joining two vertices, and that is you can see here the diagonals for this convex polygon. If you are drawing, this will be, this is another diagonal, this is another diagonal, this is another diagonal means what? Just joining two vertices, then you will get the diagonal. So this is another diagonal. In all these cases, you can see that all the diagonals are lying inside. Okay, so that is the next property for convex polygon, that is diagonals lies inside. Okay, but what about concave polygon? You can see that some of the diagonals may lie outside also. Okay, here you can see that this is a diagonal which lies inside the polygon. But if you are joining these two vertices, then you can see that this diagonal is lying outside. Okay, this diagonal is lying outside. So in the case of concave polygon, you can say that some of the diagonals may lie outside. Okay, so that is the second property for convex polygon. Okay, so let's write it. So the second property is that diagonals lies in interior of it. Okay, but what about the concave polygon? In the case of concave polygon, you can see that some of the diagonals may lie exterior also. Okay, so you need to study only these two properties. Okay, that is, these two are the main properties for concave and convex polygon. Okay, so for the convex polygon, you can see that no line segment goes inside, but for concave polygon, some of the line segments may go inside. Okay, and in the case of diagonals, for convex polygon, all the diagonals lies in interior of it, but in the case of concave polygon, some of the diagonals may lie exterior. For example, you can see this diagonal which lies exterior. Okay, and so these two are the main differences. Okay, so you understood what you mean by a convex polygon and a concave polygon. Okay, and this you need at least 4 sides to draw a concave polygon. Okay, but in the case of convex polygon, you can see that by using 3 sides also you can draw a convex polygon. For example, a triangle. Okay, you can see that a triangle can be drawn using 3 sides, which is a convex polygon. But for drawing a concave polygon, you need at least 4 sides. Okay, without 4 sides, you cannot draw a concave polygon. Understand? So I hope you understood the main difference between a convex polygon and a concave polygon. Okay, and you should be able to identify whether a polygon is convex polygon or a concave polygon. Okay, and in this chapter we will be dealing mainly with what? With convex polygon alone. Okay, so that's all about convex and concave polygon. And now we have to see what you mean by regular and irregular polygon. Okay, so let's see it. Now let's study the concept of regular and irregular polygon. That's very easy. Here also let's draw a picture and explain. Okay, so I have drawn pictures of regular as well as irregular polygon. Okay, so these three are regular polygons and these three are irregular polygon. Okay, so what is the difference? The main difference is that they are all polygons, but what is the difference? In the case of regular polygon, you can see that all angles will be equal and all sides will be of equal length. That means they will be both equilateral and equiangular. Okay. In the case of regular polygon, you can see that all the angles will be equal. That is equiangular. Okay. That means this angle will be equal to this angle will be equal to this. Okay. That means all the angles will be equal. Okay, here also you can see that all these three angles will be equal. Here also this will be equal to this. Okay, all angles will be equal. That is what? Equiangular. Okay, but in the case of irregular polygon, you can see that angles may not be equal. Okay, that means all the angles may not be equal. Some may be equal, but all may not be equal. Okay, and equilateral means what? All the sides will be equal. That means this will be equal to this. Okay, all sides will be equal. Here also you can see that all sides will be equal and here also all sides equal. Okay, so such polygons are called what? Regular polygons. Okay, so all sides will be equal and all angles will be equal. For example, equilateral triangle. Okay, where all angle is equal to 60 degree and all sides equal. And a square is also an example for regular polygon. Square means what? All sides equal and all angle 90 degree. A regular hexagon. Okay, this is a regular hexagon with 6 sides. Here also you can see that all angles are equal and all sides are of equal length. Okay, now let's see the second case, which is irregular polygon. Here you can see that it's a rectangle, but here all sides are not equal. This side is equal to this and this side is equal to this. Okay, some sides are equal but all are not equal. That's why it's an irregular polygon. And here also, here sometimes sides may be equal sometimes, okay, may or may not be equal, but angle here you can see that angles are not equal. One is 90 degree and the remaining are not 90 degree. Okay, a right angled triangle is an example for irregular polygon. And here also you can see that this is an hexagon with six sides, but here you can see that angles are not equal and sides are also not equal. Okay, so for a regular polygon, sides and angles both should be equal. Okay, all angles should be equal and all sides should be also equal. If only one condition is satisfied, then also you cannot call it as a regular polygon. Okay, so that's all about regular polygon and irregular polygon. So I hope you understood this. Today we have discussed about what you mean by a polygon, what you mean by a convex and a concave polygon, and what you mean by a regular and irregular polygon. I hope you understood that. Okay. Now I will draw a figure and you have to tell me whether it's a convex polygon or a concave polygon. Okay. So tell me, is it a convex or a concave polygon? What was the condition for convex polygon? No line segments lies inside. Okay, but here you can see that these two line segments are lying inside. And what was the second condition? Diagonals lies interior of it. Okay, all the diagonals will lies interior, but here you can see that this diagonal is lying exterior. Okay, that means what? This is a concave polygon. Okay, this is a concave polygon. Understand? Now I will draw another figure and you have to tell me whether it's a regular or irregular polygon. Okay, this one, is it a regular or irregular polygon? Here you can see that all sides are equal, that is all sides are of equal length. But what about angles? Angles are not of equal length. Okay, that means what? This is an irregular polygon. Okay, for a regular polygon both angles should be equal and also sides must be equal. But here sides are equal but angles are not equal. Therefore you can consider it as an irregular polygon. Okay. So that's all about the introductory part, and we will discuss the exercise question in the next part. Okay, so that's all. Thank you.